Hi there. This section or this video is for folks who weren't able to come to class. You missed some notes in class. You still needed to hear what I had to say a little bit more. Use this as you need. So this is guided notes for 1.3. This is part of the prerequisites for college algebra and trigonometry. And the first thing you should do is also make sure you've read through 1.1 and 1.2 to make sure we're comfortable with those as well. If there's any questions you have, please make note of them and discuss them with me in my office hour, or shoot me an email and let me know what you're struggling with. Okay. The first one is a hardware store sells 16-foot ladders and 24-foot ladders. A window is located 12 feet above the ground, and we have this display here. A ladder needs to be purchased that will reach the window from a point on the ground 5 feet from the building. Which ladder should we buy? Okay, well, in order to solve this, you just need to use, because it is a right angle, that it's creating, because here's the wall and here's how far away it is. So that's a perfect right angle. And any side directly across from a right angle is a hypotenuse. And so therefore we can use Pythagorean theorem to solve this. Okay, so I'm just going to arbitrarily choose 12 feet for A and 5 feet for B. Okay, so 12 squared is 144, and that's feet squared. 5 squared is 25 feet squared, and that's equal to C squared. We have to add these two together, and it looks like we get 169 feet squared is equal to C squared. Okay, here's where you need to understand that if you have a number equal to a variable squared, in order to get rid of that square, the opposite of a square is a square root. So we've got to take a square root of both sides. We'll be able to solve for the C that we need by taking the square root of the other side. So C equals square root of 169 is 13, and that just becomes feet. If you need to know for your calculator, just take the square root of 169 and you should get 13. So if this is 13 feet, we still have to answer the question because this isn't the answer. The question was, which ladder should we buy? Well, we could buy either ladders, but I can guarantee you the 16-foot ladder is going to be cheaper than the 24-foot, and the 24-foot is going to go up so high, it's going to be almost twice as long as what you need. So I would go with the 16-foot ladder. We should buy the 16-foot ladder. That is answering the question. Okay. Make sure that as you're going through any of the questions in your homework, in your quizzes, in your exam, that you make sure that you answer the question. Okay. All right, evaluating square roots. Now, if you took 550 prior to this class, you did not see any square roots. So I want to give you just kind of a quick rundown. If you're struggling with this, we can work on it, but I'm not worried about it until we get into chapter 2 and moving forward, because again, these are prerequisites. I'm not going to give you an exam over chapter 1. It's only going to start on chapter 2. This is just kind of a preview of things that you need to make sure you're comfortable with, or at least seen a couple times. So evaluating square roots. The radical is the square root symbol. The radicand is the number inside the square root, and the radical expression is the entire thing. Not something you need to memorize. So it's just knowledge. So the next question is, does the square root of 25 equal plus or minus 5? And the answer to that is no, because the square root of 25 is just equal to 5. If you put square root of 25 in your calculator, you're going to just get positive 5. The folks who are thinking the answer was yes are the same folks who are doing this. What am I thinking here? Oh, wrong way. X is equal to the square root of 25, and square root. There we go. So when you do that, x is equal to plus or minus 5 because you have to square both sides of this in order to get it to come out of there. Okay. All right. So the next one, I'm not so worried about these. Evaluating square roots. And you can just use your calculator for a good portion of this. In fact, it looks like all of these we can use our calculator for. For A, if you just plug in the square root of 100 into your calculator, you're just going to get 10. For B, if you take the square root of 16, I'm going to break that down. I'm going to start with the inner square root of 16 and leave the outer one. Square root of 16 is 4. Square root of 4 is 2. Okay. For C, the square root of 25 plus 144. Now, down here, it has a Q&A. For 25 plus 144, can we find the square roots before adding? That just means they're wanting to go, okay, the square root of 5, well, we wouldn't even do that. We would just have 5 plus 12 is equal to 17. Well, that is wrong. You have to add inside the square root first, and that gets you the square root of, what is that, 169? And the square root of 169 is 17 is 189. It's 13. Yeah, it's 13. I just did it. All right, and then D is the square root of 49 minus the square root of 81. Square root of 49 is 7. Square root of 81 is 9. So the answer is -2. Okay. And for each of these examples, you're going to have a do a try it before coming back to class so that you're comfortable with what we have covered. If there's any questions you have, please make sure that you make a note of that and discuss it with me before we get any further into the class, because I don't want you to get left behind by any stretch of the imagination. Okay. All right. So let's look at product rule for simplifying square roots. This is just something nice to have in your artillery or your ammunition for handling math problems. So if A and B are both non-negative, so they're positive numbers, the square root of the product, the square root of A times B, is equal to, you can break them apart into square root of A times the square root of B. All right. So in this case, for A, we've got the square root of 300. Now, some people break it completely down into primes. If you already know some of your perfect roots, square roots, like the square root of 100 or the square root of 16, 4 squared is 16, 10 squared is 100. So my first thing is I'm going to break this down into the square root of 100 and then times the square root of 3, because I know the square root of 100 is just 10. And so my answer is 10 square root of 3 for A. All right, let's look at B. And that is just the square root of 162, A to the 5th, B to the 4th. All right, because this is square root, that's assumed there's a 2 in here. All right, so you need 2 of the same things in order to pull it out. So 162, the first thing I'm going to do is see if that's divisible by 4, because I know 4 is a square root. I'm dividing 162 by 4. Well, that doesn't work. But I can, now that I'm seeing that, 162 divided by 2 is what? Oh, 81. Perfect. Well, the square root of 81 is 9. So I'm going to break this down into 2 different ones. The first one's going to be 81, and it leaves me a 2. And then for A to the 5th, you need to have even numbers since it's a square root to pull out. So A to the 4th, and that leaves me an A, because A to the 4th times A is A to the 5th, and then B to the 4th. So that's going to give us 9, A squared, B squared, square root of 2A. And that's our answer for that. All right. Using the product rule to simplify the product by multiple square roots. So the first thing I'm going to see when I do this is I just want to multiply them. Square root of 12 times square root of 3 is equal to the square root of 36. Well, the square root of 36 is just 6. So there's that one. All right, next one. This is going to be a little bit different. So it's not really. It's the same thing as with multiplication. If you have the square root of A divided by B, you can break up that square root and just take the square root of the numerator divided by the square root of the denominator. That's all this means. But b cannot be 0. Can't have a 0 in the denominator. It's undefined. All right, so let's use the quotient rule to solve this next one. Square root of 5 over 36. And that can just break down to the square root of 5 over the square root of 36, which is equal to square root of 5 over 6. That's it. And that's how you would leave that. All right, example 5. Using the quotient rule to simplify an expression with 2 square roots. Simplify the radical expression. So we have the square root of 234 x to the 11th y over square root of 26 x to the 7th y. So I just took that and went one way. We can also take it and go back the other. So this entire thing I'm going to put under one big radical. So 234 x to the 11th y over 26 x to the 7th y. All right. The reason I want to do that is I want to see if 234 is divisible by 26. Heck yeah, it is. All right. So that just means we have, I'm going to keep my square root. I'm not doing anything exciting. 234 divided by 26 is 9. And that becomes a 1. X to the 11th divided by x to the 7th. We can just move the x to the 7th to the top and subtracting 7 from both. So that's x to the 4th. And then the y's, y divided by y is just 1. So we're left with the square root of 9x to the 4th. There's just nothing in the denominator. Square root of 9 is 3. Square root of x to the 4th is x squared. And that's our final answer from that one. All right. Adding square roots. So in order to add square roots, they have to have the same number underneath the radical. We cannot go 12 plus 3 in this case in order to add these. You're not going to get 7, the square root of 15. That's not how this works. So instead, I'm going to take 5, the square root of 12, plus 2, the square root of 3. And square root of 3 can't be broken down any further, but so that just means I want to take my 12 and see what I can do for that. Okay, so that gives me 5, square root of 4, square root of 3, plus 2, square root of 3. I always bring everything down so I don't lose anything along the way. So that becomes 5 times 2, square root of 3, plus 2, square root of 3, is 10 square root of 3, plus 2 square root of 3. And yes, this could be more steps than you need. That's okay. This is strictly to make sure that I don't lose anyone along the way. Because the square root of 4 becomes 2. Bring down everything else. 5 times 2 is 10. Now that they both have the same square root of 3, I can add the 10 and the 2. So this becomes, for my final answer, 12 square root of 3. Okay. Again, let me know if you have any questions on this. Subtracting square roots. So again, what's underneath the radicals need to be the same in order for us to combine them, either be by addition or subtraction. All right. So I'm going to rewrite these up here. Makes it a little easier to see sometimes. A cubed B4C minus, it's all under the radical, 14 square root of 8 A cubed B4C. So I'm thinking we want it to look like this in order for us to pull these out. So 72 breaks down into what? 72 divided by 8 is 9, now that I think about this. So 20, the square root of 9, the square root of 8 A cubed B4C minus 14, 8 A cubed B4C. And the square root of 9 is just 3. So 20 times 3. And then everything else is the same. Again, this is probably too much for some of you. Please do not be offended that I'm doing this. Just ignore it if you already know it. 20 times 3 is 60. All right, now what's underneath the radical is exactly the same. I can combine the terms 60 minus 14. I think that's 48. 46. I keep doing them. So that answer is 46 square root of 8, a cubed, b 4c. Now that I've got these combined, I can reduce them further because the 8 will break down and we can pull out numbers there. The a cubed will break down. We can pull out numbers there as well. The b as well, but not the c. So I'm going to keep the 46 the same. I'm going to come over here where I have more space. So I've got 46. The square root of 8 breaks down into 4 and 2. All right, so that's going to be a 2 times 2. And I'm going to have some stuff left under the radical. And the first one is going to be a 2. And then a cubed will break down into 8 square and 8. I'm sorry, a square and a. So I can pull out an a, left with an a. B, square root of b4 is just b squared. And then the square root of c is going to be c, square root of c. All right, so 46 times 2 is 96. And then we've got a, b squared, the square root of 2ac is our final answer for this one. Okay. Yes, a lot of steps. No, you don't have to do all of this. Again, it's just to make sure that you've got all the steps covered in case there's any place that you messed up and you didn't get the same answer as me. And then you can find it. All right, rationalizing denominators. Now, if you took 550, you most certainly did not learn how to do this. What you basically need to understand is you cannot answer a question with a square root in the denominator. All right, so if you do that, it is incorrect mathematically. And the most important thing is we're going to have, it's like a little puzzle to figure out what you need to multiply by in order to get rid of that square root that's in the denominator. So let's look at an example here. All right, I want to do a simple one first before I get to this. So whenever it says rationalize the denominator, so say you have 1 divided by the square root of 5. All right, you cannot have, that's an answer. It's an incorrect answer because you cannot have a radical in your denominator. So in order to get rid of that, it says to multiply the numerator and the denominator by the radical that's in the denominator. So that's just multiplying the numerator and the denominator by the radical in the denominator. So that ends up giving us the square root of 5 over the square root of 25, which equals the square root of 5 over 5. Okay, that's all rationalization of the denominator means. So now we can go to the harder one back here. And I wanted to cover that before I got to this one because it can get really overwhelming if you've never seen it before. And that's not my goal for you. All right. So we're going to write this in the simplest form. So we've got 2 to the square root of 3. It's okay to have radicals in the numerator. It's not the denominator. Divided by 3 square root of 10. Okay. So they just told us to multiply both the numerator and the denominator by the radical itself. And that will get rid of it. So that gives us 2 square root of 30 over 3 square root of 100. Square root of 100 is 10. So that's 2 square root of 30 over 3 times 10, which is 2 square root of 30 over 30. But this can reduce. 2 and 30 can reduce. All right, by 2. 2 goes into 2 one time, and 2 goes into 30 15. So the answer is square root of 30 over 15. Okay. All right. Given an expression with a radical term and a constant in the denominator, rationalize the denominator. Okay, so this is what we're going to have to do a conjugate for. And it says here to multiply the numerator and denominator by the conjugate, and then use the distributive property. All right. So the conjugate of 1 plus the square root of 5 is 1 minus the square root of 5. Anytime you're dealing with a binomial like this, it's going to be 1 minus the square root of 5. So let's write that. 4 divided by 1 plus the square root of 5. And the directions are telling us to multiply the denominator, numerator and denominator by the conjugate. The conjugate of 1 plus the square root of 5 is 1 minus the square root of 5. So that's what I'm going to do. 1 minus the square root of 5, 1 minus the square root of 5. I'm gonna put parentheses around this so it makes more sense of what we're doing. Okay. And then we're going to distribute. To distribute, we're just multiplying the terms by everything in the binomial. So 4 times 1 is 4. 4 times negative square root of 5 is negative 4 square root of 5. Numerator's done. Now for the denominator, you can go 1 times 1, 1 times negative square root of 5. We'll do that. So 1 times 1 is 1. 1 times the negative square root of 5 is negative square root of 5. And then square root of 5 times 1. And square root of 5 times negative square root of 5 is negative square root of 25. Okay. All right, let's combine like terms. The numerator stays as it is. And the denominator, we've got 1. Negative square root of 5 plus square root of 5 is 0. And then we have minus the square root of 25 is just 5. So we've got 4 minus 4, the square root of 5, over negative 4. All right. So far, we're good. Here's something you need to understand if you're not comfortable with it or you don't understand it. I want you to know that if we have a 1 over negative 4, it's just I'm just a side thing here outside of this. This negative can be negative 1 over 4 or negative 1/4. All three of these are exactly the same. Okay, you need to understand that. That being the case, this negative down here in the denominator, it's not that I don't like it. It just makes it harder to deal with what we're going to have to do, or ever. I mean, any problem. I would never leave a negative in the denominator just because it doesn't make sense in my head. So the first thing I'm going to do is I'm going to move this negative to the numerator. Okay. That's the first thing I'm going to do just to make a little bit more sense. So when I do that, it doesn't just go to the 4 here. It changes the sign in front of this 4 as well as this 4. So that's what I'm going to do right now without doing anything else. I'm just going to make this a negative 4 plus 4 square root of 5 over 4. Okay. Now I'm going to break these apart. That might be easier for you to see because people tend to forget one if you don't do this. You can reduce these three, and I'll show you how that looks broken apart. Negative 4 over 4 plus 4 square root of 5 over 4 becomes negative 1 plus the square root of 5. 4 divided by 4 is 1, and it's negative, plus 4 divided by 4 is 1, which anytime there's no number in front of the radical, it's an assumed 1, and then square root of 5. So this is our final answer. Okay. All right, next one. Principal nth root. If a is a real number with at least one nth root, then the principal nth root of a is written as the nth root of a is the number with the same sign as a that when raised to the nth power equals a, and the index of the radical is n. All right. Well, what the heck does that mean? Well, let's look at some examples. The big thing here that they're looking at is we're not dealing with square roots at this point. Remember, square roots, there's an assumed 2 there. So you have to have 2 of the same thing in order to pull it out. In this case, the first one is the 5th root of the square root of negative 32. If the root is an odd number, the negative comes out. Okay. So because it is a negative with a 5th root, our answer is going to be a negative answer. So the 5th root of negative 32, it's going to be a negative, and then the square root of 32 is just, the 5th root of 32 is just 2. Let me show you how you can use your calculator for that. When you're dealing with, well, actually, I want to come down here and I can show you a little easier. This is what I'm going to do. So I'm taking a to the m over n. That just means power over root is what this is. So if we've currently got the 5th root of, well, let's do that. We've got the 5th root of 2 to the 5th. That's basically what this is. The 5th root of 2 to the 5th, and that's a negative, is equal to -2. Okay, so if you come down here, this is where I'm going to use it. This is the same thing as a power over root in the exponent. And you can use your calculator to put, since this 32 up here is, it has got a 1 automatically up here for its power. All right. So in my calculator, I would come over here to the side and go, okay, my calculator 32, raise it to the power of 1/5. You can even put the negative in there. I'll show you. So I'm going to put negative, let's see here, 32 negative, raised to the power, open parenthesis, 1 divided by 5, close parenthesis, equals -2. That's how they get the answer. Okay. So I'm going to write 32, caret, or y to the x, whatever you've got on your calculator, open parenthesis, power over root, close parenthesis, equals. All right. Let's look at B. We've got the 4th root of 4 times the 4th root of 1024. Well, the first thing I'm going to do is multiply what's underneath the radicals and get the 4th root of 1024 times 4 is 4096. Now, what I'm going to do in my calculator to find out what the 4th root of that is 4096, and then raise it to the power of 1 divided by 4, power over root. So raise it to the power of, open parenthesis, 1 divided by 4, close parenthesis, equals. And the answer is 8. Okay. Let's look at C. It is a negative cube root of 8. Oh gosh, I can't see that. Let's see if I can make it bigger for me. 6, 8x to the 6. 8x to the 6 divided by 125. Okay. And it's a cube root. Well, I'm going to break these up. I'm going to do the cube root of 8x to the, cube root 8x to the 6 divided by the cube root of 125. All right, again, use your to the 1/3 instead of 1/4, and that's going to equal negative, first of all, because we've got a negative here. Cube root of 8 is 2. Cube root of x to the 6 is just 6 divided by 3, because power over root is x squared, over cube root of 125 is 5. And that's our answer for that one. Okay. And then D. 8 4th root of 3 minus the 4th root of 48. Well, in order to combine these terms, what's underneath the radical needs to be the same. So I'm taking that 48 and dividing it by 3 to find out what I'm going to hopefully be able to pull out of here. So 48 divided by 3 is 16. Okay. So 8 4th root of 3 minus, I'm going to break these down, 4th root of 16 times the 4th root of 3. The 4th root of 16 is 2. 2 squared is 4. 4 squared is 16. So I've got 8 4th root of 3 minus 2 square root 4th root of 3. 8 minus 2 is 6. 4th root of 3. And that's the final answer for that one. Okay. All right. This is a long video. Hopefully I won't make the rest of these too long. So let's see here. Given an expression with a, make sure you have this in your notes as well. Okay, so that you've got this. Given an expression with a rational exponent, write the expression as a radical. Determine the power by looking at the numerator of the exponent. Determine the root by looking at the denominator of the exponent, and use the base as the radicand, raise the radicand to the power, and use the root as the index. All right, let's look at that. So write rational exponents as radicals. They just want us to take what they've given us here and to write it as a radical and then simplify. So what we need to understand here is power over root. If it's in the exponent, It's power divided by root. So we've got 343 raised to the 2/3. The 2 is the power, and the 3 is the root. So I'm going to go cube root of 343. And now you could put it like this, or you could put it, which I like to do, because it deals with smaller numbers. I like to do that. And this makes more sense to me. Okay. So the first thing I'm going to do is, you don't even need to do all this. This is just a representation. Because you're using your calculator, you can just take 343 and raise it to the 2/3. Okay, then you're not actually having to write it like this. And being the fact that this isn't going to be on your exam, this is just an understanding of how to utilize this. You don't even need to do this. What you need to do in your calculator is 343, raise it to the power, open parenthesis, 2/3, close your parenthesis, and equals. And the answer is 49. That's all you have to do. Okay. Utilize your calculator given the opportunity. All right, the next one, we've got a radical in the denominator, and that doesn't work for us. So we need to find out what we need to do, multiply this by, in order to change things. Now, earlier we talked about just multiplying the numerator and denominator by the root itself. But if we do that, it's still not going to be right. We're still going to have a radical in the denominator. All right. So we're going to have to do something a little different here. What you need to understand is you have to have 7 of something in order to get rid of this radical. And currently we only have 2. So how do we make this 2 into a 7? Well, we're going to have to multiply by the 7th root of a to the 5th. And I'll show you why. All right. So our numerator is 4, 7th root of a to the 5th. This one becomes the 7th root of a. 5 plus 2 is 7. 7th root of a to the 7th is just a. And that's our answer. Okay. So you need to find out what's still missing under the radical in order for you to pull things out. The only time you, really struggle with this, we'll really struggle with this if it's something other than a square root, because that's when you really need to think about changing. It can't be the exact same thing as the a squared. Okay. It has to manipulate in order to pull 7 of them out, or whatever radical you're dealing with. All right, and this is the last portion of this. So we've got, looks like 2 more. Simplifying rational exponents. So 5 times, all right, let's do this. I don't remember doing this in class. 5 times 2x to the 3/4 times 3x to the 1/5. Okay, when you combine, when you multiply your bases, you add your exponents. When you multiply your bases, you add your exponents. And in order to do that, we can do 5 times 2 times 3 easily. 5 times 2 is 10, 10 times 3 is 30. Numbers done, boom. But now we have x to the 3/4 times x to the 1/5. Okay, that's what we have left. And in order to multiply these, we have to add the 3/4 and the 1/5. So I'm going to do old school. 3/4 plus 1/5. And it looks like 20 is going to be our denominator. 5 times 4 is 20. 1 times 4 is 4. 4 times 5 is 20. 3 times 5 is 15. Add the numerators, 19 over 20. So once we do that, we've added our exponents. We've got x to the 19 over 20. And that's our answer on that one. All right, B. We've got 16 over 9 raised to the negative 1/2. Well, power over root is great. This is just going to be a square root. But we have a negative. Negative means inverse, so we have to flip our fraction. So to get rid of the negative, we'll start by going, okay, 9/16 to the 1/2. Negative's gone. Boom. So now we've got the square root of 9 over the square root of 16. Well, actually, it comes out to the square root of 9/16. And I'm going to do it like this instead. Okay. So square root of 9 is 3. Square root of 16 is 4. And that's our final answer. All right. Looks like we've got a real world application. A car accelerates at a rate of 6 minus the square root of 4 over square root of t meters per second squared, where t is the time in seconds after the car moves from rest. Simplify the expression. Well, we can't have a square root in the denominator. Okay, so how are we going to do this? We can't combine the terms without them having the same. So, oh, excuse me, just one second. Pause. Okay, this is going to be a fun one. So the first thing I'm going to do is make sure that I can add these two terms or combine them in whatever fashion I can have. So I've got 6 minus the square root of 4 over the square root of t. I could just rationalize. Yeah, we could just rationalize this one here. So we should be able to just multiply by the square root of t over the square root of t. Square root of 4 is just 2. So that's equal to 6 minus 2 square root of t over t. There's another way. There's many ways we could do this. We could have multiplied the square root of t times 6. Let's see if that does it. Now, this is fine. Let me see if I get the same answer the other way. So 6 square root of t over square root of t minus, I'm going to go ahead and do that to 2 square root of t over square root of t. Oh, this should be t. Oh yeah, that would be nasty, because then you've got to, then you have to end up multiplying everything. Nope, I wouldn't do it this way. It takes too long. I would strictly do it this way, just to make sure that you've got it. The t is gone, and you've rationalized your denominator. Okay, that's it. I'll hit 1.4 next. See if I can stop. There we go. Oh, I am not technically savvy. Here we go.